And as you look at the databases with the constraints in mind, one of the interesting things is even though the analytic market is very, very crowded, most of the options that are out there do not either do not solve the problem, or if they do, they do not meet all the requirements or the constraints. So with that in mind, Yandex, saw things similarly at the time that they began to develop this. What they came up with was ClickHouse, which fills those gaps that are not met by the current products, but also does much more besides. And so here's just some general reasons where if you met somebody and they said, hey, why, and you ask them, why is ClickHouse good? Well, there's a number of things that it does well. First of all, it understands SQL. So if you're used to dealing with SQL queries, and I think if you're on this call, you're probably somebody who's used SQL before, this is going to seem pretty familiar. It's portable. It runs on anything from bare metal to cloud with containers in between. It stores the data in columns. So this is actually very important because it gives us enormous efficiencies in the amount of IOs that we have to do on read. It also means that we can do those IOs both for read and writes very efficiently by always doing sequential IO. And this is important because it allows us to use hard drives very efficiently as well as other storage types. It has parallel and vectorized execution. So parallel in the sense that both within a single host, we use all cores and all hardware threads on those cores. And then across host, we have the ability to parallelize the processing very efficiently. Vectorized means that we're focused on using processing things in vectors that can take advantage of SIMD instructions. So that's single instruction, multiple data. And these can lead to enormous efficiency gains. Scales to many petabytes. It's open source, so no licensing problems, and it's way fast. And I think that when people talk about ClickHouse, it's the speed that really impresses people. And that's the number one thing that people mention. So what do we mean by way fast? Well, here's one of our favorite data sets. It's airline on-time data, comes from the US government, and it basically tracks the on-time performance of the US air carriers over the last 30 years. And what we have here is a query which is just looking at the destination airports, counting them up, and then checking the average delay minutes for each of those airports. And we're basically looking for the airports that on average over this time have had the biggest delays. So we run this query and it comes back in a second. It processes over 170 million rows. And then we get our answers. So this thing is really quick. This is on an Amazon machine, not particularly capable. It does have fast storage, but it's definitely not a monster by any means. So this is what we mean by fast.